Hi, good morning. Thanks so much for joining me. Hello from Canada, from Ontario, from Aurelia. What's special here in Canada is that July 1st, just a couple of days from now, is Canada Day. That's a day where Canadians celebrate just being Canadian. And but this year is very special because it's been 150 years since the original formation of Canada. And so we're celebrating that, and the funny thing is, it's not really funny, but I live in a town or a small city, Aurelia, which is also celebrating 150 years since the town I'm in was incorporated. Now, that's pretty old for Canada. Actually, this area is one of the oldest areas in Canada, although you wouldn't think so if you came and visited here. It doesn't seem like it's one of the oldest, but this is one of the first places Europeans settled in North America, right around here. So what am I showing you? Well, let's see. I showed you a moose a couple videos ago and then admitted it was a Swedish moose, but in this case I'm showing you this is a bona fide Canadian moose with a colorful piece of Canadian rock. There's a lot of this kind of stuff around, especially a town called, I think it's Bancroft. Wow. It's a mineral capital of the world. So anyway, there is a Canadian moose. Looks a little emaciated, doesn't he? But that's what a Canadian one looks like. Huh. Okay, now what are we doing with this radio today? I think what I'd like, there's lots of options here of what to do next, but I think what I'd like to do next is poke around with all the capacitors that are in this radio. It doesn't look like many of them have really been fixed up, replaced, dealt with, or anything. So I think this guy's running on original capacitors, and let me just show you what I'm really talking about here. Just disconnect a few things. Also, thank you very much to one of you. I won't name you, but I do get emails from some of you. And one of you has sent a link to an article or a report, I don't know what to call it exactly, about this exact radio, someone else restoring it, and in that person's story is a couple of things that are really important for me to find out. And one of them is, I now know what these things are, these guys here. So these are actually small capacitors. In the last video I discovered that there was a little bit of, well, what I'm sure is mica between these plates under here, and then tightening these screws will squeeze the mica and change the capacitance right here. This is like just a wide open to the world capacitor sitting right here, and I believe this is what is bridging the signal from one tube to the next. No, that's not right. I'll take that back. Just erase that. There are coils that are passing the signal from one tube to the next. Transformers doing it. These are neutralizing capacitors. Something I don't know an awful lot about, frankly. So I'm probably going to end up learning quite a bit more about it. So now these are not the capacitors I think are a problem. Although they may require some kind of adjustment. Capacitors I'm after are down here. These guys. So these are, well, they look like they've never been taken off. Hard to say. These are the original capacitors, and they are sitting here. And I'm sure, well, how sure can I be? I'd be stunned if these are good. So we're gonna test these guys here today. Good. And I'm so certain that these are going to be bad that I think I'll probably just cut these circuit wires away. So when I test them, they're not in the circuit at all. But where are these occurring? Let's take a little bit of a closer look at them before we go hunting on the schematic. They look identical, but they're not wired identically. You can see there's two terminals here, and there's only one here and one here. The second terminal on these guys has been bent back and soldered to the can. And then you can see a solder wire here looping through each can, and then pretty firmly soldered, and this rather unusually large screw holding it down here. That's really bizarre. That looks like a mighty expensive screw there. There's another big one down here. Why are you using such big screws? What is this one doing? So the screw comes up through this chassis and actually gets right up into the metalwork of this tuning area here. There's quite a frame or sub-chassis, if you like, holding this unit here. You can see it here, and that big-headed screw is coming up inside of it. So maybe that's why they got a big-headed screw there. Really make sure the grounding is effective, I guess. Okay, now what is inside these? Don't know exactly. Frankly, I can guess. Could be some tin foil in here. Could be some metallized paper, maybe. I really don't know, to be honest with you, how this is constructed. It's almost certainly potted, which means if I open these up, inside will be a whole bunch of tarry-like compound. And one terminal's got to be positive, and one's got to be negative. Well, not necessarily. I don't know that these are electrolytic. I don't know what they are. I don't know what they are. Okay, let's see if we can find them on the schematic. How would we identify these? They This one's not, although the can is grounded. Neither terminal is. So this one's done a little differently. These two guys are grounded. You could guess this is a positive terminal then. I could turn the radio on and measure this stuff too. See what's going on. I'm more inclined to just test these capacitors and look at replacing them. And the other issue is, how big are these? What is their size? Wow, that depends if they're electrolytic or not. Okay, let's go take a peek at the schematic and see what we can find out. Okay, here's the schematic here. Capacitors are part of the radio circuitry. Look at this one, and this one to the chassis, This one's also to the chassis. So there's three of them here. These two are hooked up to this filament line, which is feeding the filaments. I'd be suspicious these two are in trouble. I don't fully understand how all this is actually working out. I don't really understand why you'd want to have two capacitors here, but I'm sure the explanation would be quite sensible. 1, 2, 3, boom, boom, boom. Are they 37 bypass condenser, 1 microfarad? That's pretty big. 38 bypass condenser. 38. 38. Somewhere in here is a 38. Wow. Let's see. 37, 38, and 43, and 36 are all bypass condensers. Bypass. Let me find any one of them. So here's 37. What's it doing? It's grounding the plate line. That term bypass, you know what, I'm not so sure about that term myself. Look at these guys up here. Here's a bunch up here too. There's something, looks like it's going from the grid, What is going on there? Some feedback happening. Okay, so these are those neutralizing capacitors right here, I'm pretty sure. Maybe this one too. There's 3 of them here. They all go to the chassis. I've got 2 and 1 not to the chassis. It's quite the guessing game. Here's another one. Way out of the front. I think I'm going to have to trace the wires back from the capacitors I'm curious about and see where the wires go, and then from there I can identify what they are. So big, let's see, there are a couple, these are the filter capacitors in the power supply. Bigger yet. This one's fairly big, 0.5. So we got a 1, a 1, and a 0.5. But so this list is not exhaustive here. This is just a few key parts, I think. I don't know why they only show us these parts. The rest of them are not in the list, so that doesn't mean there isn't more that might be called bypass and stuff like that. Okay, I'm gonna have to do a wire tracing thing. Maybe the best way to do this will be with my meter here. We'll just see if we can find, well, continuity to ground here. We shouldn't find it here. Should find it here. Come on. Okay, let's make sure the meter is set on the right setting back there. We're just listening to it here. Well, I might as well move it over here. Okay. Oh, that's unexpected. That's doubly unexpected. Huh? This might be a really bad actor here. A really bad actor. Ooh. Look at that. Now that could be because of where it is in the circuit. It could be the other components are resulting in that. That's a little bit surprising. If the other things in parallel with this have a resistance of almost nothing, what's this doing here? How does this help anything? That's something. Okay, let's find out where this is in the circuit. So these 2 wires both go into this cable. And from there, we don't know. I've got something else exciting happening in my life. I've waited all this time until I'm this old to buy a bona fide telescope for looking at stars. Can you believe it? I've waited all this time. I bought 3 or 4 telescopes at yard sales, all of them children's toys. But I actually bought a real telescope. Not expensive. Less than 200 bucks. World's most popular backyard telescope. It's coming here for Friday, just in time for a bad weather. So, but anyway, that's exciting for me. What am I doing? I was going to do something here, and then kind of lost track. Got all excited about my... Get right around the back. So what I'm going to do is we're going to have to manipulate this a fair bit. Let's get the... get this plug out. There we go. So this is it here. Comes up and connects to pins on a tube. Excellent. I can figure out, be able to figure out what those are. Excellent. Okay, so, and this tube is this is the number 1 tube. This is the first tube. Okay, and it's connected. You know what that is? That's the capacitor. I don't know what that is. What am I talking about? Do you know what that is? So these are the heater terminals all along the back here, the large pins. And these 2 wires come up and they attach on either side of the heater wires, and then the heater wire just skips along through the tubes here. So that's that capacitor. This capacitor. Right across the tube elements. That would explain why when I put a meter on here it looks like a short. It's not necessarily a short, it's because of these tubes. Let's get rid of it. Now, I've got tubes everywhere in here. More highly organized confusion going on. So I think what I've done now is I pulled out the heaters from the circuit, and so it should be open now. So I can get at the terminals here. That's between terminals. And that's the ground. That's a little more sensitive here. It's a 20 megohm scale. Yeah, it doesn't, not shorted at all. These old capacitors, sometimes their capacitance is so dependent upon, I guess that is with all capacitors, pretty much the physical structure. The physical structure is still there. Minus. And a little bit of voltage inside here. Now watch it. See, it's down to 30, 20. Take it off. Stick it back in and see if it's gone up. 50. That's going all over the place. Going up. I don't have a good explanation for that. Slowly, slowly charging a very large capacitor. Could be. Okay. One of those capacitors was a dead short. I'm pretty sure that operating the radio would lead to something bad happening. So that's why even when I measured a short, I thought, no, this can't be the case. So what I'm going to disconnect the wires off of here. Wow, this one's got 4 wires on this terminal. Look at the schematic again. So I think this is the capacitor I'm playing with. See, it's connected to either heater line, but it goes to the chassis. It's possible that's how that capacitor is working. The can being grounded is this connection, and really the way it's wired, I think that's what this has to be. This has to be number, I think that says 36. One, two. Oh man. Because okay, so this is all 1. This is number 2. Where's number 3? Number 3. Where are you, number 3? I don't know. Okay, we'll have to just do them one at a time. So let's keep concentrating on what we think is this one here. Okay, let's do that. These look like the original solder joints here. This ground wire, oddly enough, they did not solder it right to the cans. Even though they did soldering to the cans here, they did not solder this wire right to the cans. And they've used what looks like a copper nut here, which all along here, a lot of copper, what looked like copper nuts. Maybe for, conductivity reasons. Steel is a bad actor in situations like this. Well, I'm going to try to get these wires off. I think that's probably the way to go. The thing is, the wire is bound to be stiff. This insulation is, yeah, I'm sure if I bend this wire, crack. And that may be one of the stories for this radio, that all these wires are on their last legs here. It's the kind of thing, if you don't touch it, it will stay exactly as it is for, decades to come. But even now, any slight movement of these wires, crack. Off comes the insulation. Once that starts, and you start replacing these wires, you're on your way to replacing them all, because as you do the work, you crack more and more stiff wires. So it's it's not a small decision. None of these things actually are small decisions. At the end of the decision is, another extra couple hours of work, potentially, stuff like that. So you got to think these things through. Of course, I never know what's going to happen next. I do lots of thinking. It doesn't pay off in a lot of cases. Really see the insulation's cracking off here. You know, another way is just cut these wires and shorten them back on when you want to put them on. Okay, there's one. Wow, okay. Crack the insulation just where I'm grabbing it with the pliers here. It's not, there's some flexibility left, so. Yeah, sometimes I like to think about you know, what surgeons go through. Not that I think this is really directly comparable, but there are some issues here that are similar. In this case, I've never thought about this, but when a surgeon goes to work on somebody who's 22, he's pretty sure what he's going to find inside the guy. Work on somebody who's 80. That must be extremely unnerving. Of course, I actually know this. I mean, there's no surprise here, right? Working on you know, surgically working on an 80-year-old is a lot different than working on a 25-year-old. Wires are off, so now we can actually test this capacitor here. Yeah, it's cracking right off here. I can feel it. Okay. We'll test this. Big capacitor, I can test it with my big capacitor tester. See if I can find some suitable test leads. Where have all my test leads gone? You see, I reorganized my shop the other day a little bit, and now I don't know where anything is, of course. Here we are. Here it is. I'll let my bench turn into quite a mess too. Shame on me. Okay, so we're going to make use of the capacitor checker here. Now, those electrolytic or not, I don't know. So we'll start with the tester set for regular capacitors. Set it to 25 volt leakage when we go to do the test. We're going to guess. That's what we're testing. Okay, you can see the eye. There we go. It's opening. Patience with the big capacitor. So at 25 volts, the eye has opened. Pretty good. But it's only 25 volts, that's nothing. 150. It's not going to, well, it's actually changing, but it's not going to open. Now, what if that's an electrolytic capacitor? Same voltage, electrolytic test. Good as can be. Are those electrolytic? Wow. Well, let's see. They're, I think the sizes are 0.5 and 1. That's a large size for a small electrolytic capacitance like that. I think these are non-electrolytic capacitors. Okay, so well, this is leaking like a sieve. I really can't. I really can't measure its value. Leaky capacitors just give misreading results, and I guess you could even argue if they're leaking that heavily, what value could they have? So we're back on a regular capacitor type check. The other side there, 25 volts. Slowly coming open. Slowly, slowly. Well, it stopped now. Slightly open. I mean, come on, is there a surprise here? No surprise. The difficulty is... No, wait a minute. It's not so difficult. I was going to say the difficulty is I don't know what size these are supposed to be, but if they are the ones I think they are in the schematic, then... And what if I put in, like, it's 1, 1.5. What if I put in 1, 1, 1? It surely can't hurt. 1 microfarad, 1 microfarad, half microfarad. I mean, if I put in 3 ones, how can it hurt? These are, they look like, these are draining signals to ground. They're just trying to get rid of them, kill them. Bigger is better. Back in the day, bigger than this is really expensive. This is expensive. Look at these things. These cost money to make. So, you know, back in the early days, things that we now think are cheap, or they are cheap. You can buy a capacitor, a 1 microfarad capacitor for 30, 40 cents. Back in the day, these were expensive guys being made. It looks like I can pull out the insides of one of these too, because it has some kind of non-metal material here, a little bending tab. It looks like you can just slide it right out, which we should really do this. We should really do this on this one. Why don't we just we'll leave these, we'll keep pursuing this one. We already know it's leaky and it's of no use. Even if I remove it from the radio now, I'll probably put it back in, because not electronically but physically, so it remains part of the history of the radio. This can come right out at this point. There's no wires connecting to this. Wow, it's a little tough to get a tool in there. Yeah, this is easy. See, these I can bend these tabs straight, and maybe the whole thing will come out. Or maybe it's in here, so you know, it may be potted in here. So what would they do? They would, feels like it's really heavy. It's much too heavy. So I think it's full of compound. Which means that it's probably impossible to pull this out. Somewhere on YouTube is a video of somebody doing this, I bet. Well, the can doesn't seem stuck. I can see it flexing through here. Okay, let's go. Let's dig in here. Let's get it on camera too. A lot of these tabs you get only a couple of shots at bending them before they break off. So I'm just going to bend this to minimum. Okay, baby. Ha, it's going to come out. Ooh, this one's going to break right off, this tab. A lot of people who do radio restoration like to take something like this apart and jam the new parts inside and then put it back in. It's an interesting idea. You get the... What's holding it? This little plate here is not doing much. It's stuck on the solder there. Yeah. Some kind of gooey tar in there. So was I actually moving the insides? sure am. This might get just totally wrecked on the way out, but I don't think it really matters. It's coming. What's it catching on? Solid knock. It's catching on something. There we go. Cool. There's no writing on it. Now, I think this might all be stuck in tar at this point. It's soft. Stick my nail in it. Now you might be going, oh my God, maybe this has polychlorinated biphenyls in it. PCB. I happen to know a fair bit about the history of PCB. That was a chemical that people talked about back when I was in college as much as people talk about global warming today. PCB is going to end the world. Was studies finding PCB chemicals in eggs and birds in the Arctic around the world, and the word was, along with acid rain and PCB, we were all doomed. So the world invested a huge amount of money to get rid of PCBs, which were excellent industrial chemicals used in all kinds of products. People don't realize it, but the major use was in electrical equipment, because it's an extremely stable molecule, has very, very useful electrical characteristics, and does not burn. That's the big thing. So that's where this chemical ended up, in all kinds of situations where you could not afford to have a fire. And then it was deemed, when I was in college, the chemical was first invented in the late 1800s, first discovered in the late 1800s, and then put to work industrially not long after that, and continued on. The brand name for the transformer oil that was laced with PCB, not laced, it's 50%. It's called Ascarel. Ascarel was the name of it. Yeah, that's what we heard. I was working in the power industry, so, you know, wow, we were the ones that had to take action. Clean all the transformer oil and tens of thousands of transformers and all that kind of stuff. What happened all over North America and maybe the rest of the world, to rid the world of the horrible PCB, which now everyone's forgotten totally about, because now it's all about the horrible global warming. And I'm not saying global warming is not real. Don't misunderstand me, but there just seems to be these things that come along when you get to be a little longer in the tooth. You've gone through a few of them, and it makes you wonder, is that all just craziness, or what? Okay, so what can I do with this thing? You can't do much with it. It's out of the can. Now think about it now. Could this can be one of the elements in this? I don't think so. You know, like the circuit diagram shows two capacitors. You know, maybe it's. I got to trace these other wires and find out where these other ones are going. Especially look at this one. Yeah, right. Yeah, look at this one. So these two guys, one terminal down to ground, two of them coming out, and look, they're going into a bundle, or they're cabled together here. Hey, that looks just like this. So it should be easy to trace this. Okay, let's find out what's going on. Let's find out. That sounds like a lifelong struggle. Let's find out what's going on. What's going on? If you're a seeker, then you've spent your whole life trying to figure out what's going on. Put that over there. Probably if you're attracted to this kind of thing, troubleshooting, playing around with radios like this, you probably are a seeker. You probably are curious about what's going on. How does that work? What can I do about it? Okay, now I've turned it around so the bundle we're chasing is this one now. Coming up through here. It's really hard to see, that's what it is. Oh, let me get my own big screen TV going here. Okay, so there is the cable in question. There's supposed to be two wires in this thing. And there's only one wire. What's going on there? Where's that wire going? Where are you going, man? Is there a hole back there? It's awfully loose. No, can't. There's no hole. It's a tube socket. So I guess I'm just pulling the insulation up and down the wire here. That's why it looks so loose. But there's only one wire. What happened? Okay, there's two wires. Ooh, hear the click? Wires here. You say the insulation is broken off right there, going into the little protective tube. Looks that way to me. Maybe not. So there's definitely two wires going into this tube. Oh, maybe I was chasing the wrong tube. Ah, it's this one down here. Okay, where do they go? Oh, they seem to be connecting. I think they're connecting to the heater terminals on. This would be the first audio tube. Okay, so maybe the schematic shows something going on with the heater circuit to the first audio tube, last tube in the radio. And you can really see the connections there. What's this orange wire then? Oh, wait a minute, am I on the... Oh, you know what? I got it totally backwards, because up here, yeah, because I've turned things around. Yeah, I sure have. So this is the heater terminals here, where these two orange wires go. So this is not, this is either the grid or the plate. It's going to be the plate, because this brown wire is also conveying B+. Okay, so now I've figured out that one of these leads, let me double check here. Hold still. So one is going to the grid and the other one's going to the plate. Two very different duties. And then, oh, when did that happen? Well, I don't know if I just knocked this off or if this has been off. Huh. That's interesting. Okay, something a little curious there. And then we have the other wire over here. This capacitor terminal is not busy. This one's got all kinds of stuff hooked up to it, including a blue wire that's really easy to trace. Okay, let's do that. Where's the blue wire go? Blue wire, it goes up into this coil. So we have this terminal connected to a coil and connected to the plate or the grid. It's the grid. This is connected to the grid. What do you got all these connected to a grid for? Grid, coil. Well, the coil could be the secondary side of the transformer. I think I can find these now. I think I can find this on the schematic. And this. Okay, let's go quickly. Without fear or hesitation. So we were just looking at this tube's heaters here, finding that there's a capacitor. There it is. So this, I'll take it back. I'm totally confused. Back up, back. So we found that one capacitor is hooked up here. There's no evidence of it at all. I got this wrong. And the other one's hooked up here. There's just zero evidence of that. What happened to me? I got all turned around. I saw those parts. I saw those wires. What? Some difference here? No. Okay. Not really, though. I really want it to be these two capacitors. 36 bypass condensers, 0.5s. I'll just have to look again, because these are clearly on the first tubes here in the schematic. I mean, they can be anywhere in the radio, in fact, anywhere on these lines. But here they're showing close to the first tube. I don't know, let's look at it again. That didn't work out. Somebody confused me. Okay, so starting again from the two capacitors. There are two wires, they come along, they bundle together here, they travel in this. There they go. I'm not being fooled here, am I? No. Clearly they're both in the tube. Clearly it's that lower tube. Clearly the wires come out. One connects very clearly to where this brownish wire is hooked up here. And the other one when we look at the tube socket, you can see the large pins are here. It all adds up because it's these smaller pins that have the wires going to them, and that's a grid and a plate. It's a grid and a plate. can see this brown wire, if we trace it back, keep an eye on it. It's in here now, and it goes all the way down to there. So it's literally a capacitor on the brown wire there. It doesn't appear in the schematic. Really? Come on. This is the brown wire, is this one right here. There. So there's one. There's another one that, so that's one. That's now the other one is tied onto here. This grid. The grid is grounded beyond this coil. Transformer. What am I seeing? Paralyzed here. So I got to look at this very carefully. Grid connection from this tube appears to have a capacitor to ground, which doesn't make a lot of sense. Putting a capacitor here doesn't make a lot of sense. So I'm going to look at it again because I must be getting fooled here. This radio is making a fool of me. Okay, so there's no question the two wires go up through here. Okay, there's just no doubt. Only doubt would be what is going on. Back here. You can see the, oh, maybe I have been, oh no, maybe not. Let's see, is that? Oh, whoop, whoop, whoop. I should just keep my mouth shut sometimes here while I'm doing this. Under that. Trying to absolutely be sure that two wires are coming out of the end of that little pipe there. The way they appear to be. Certainly appear to be. Now where's this other one? See, the thing is I may have misidentified where this one's going. This one here. This guy right here. Wow. I mean, if that's not going to that terminal, then it would be going right by the terminal. Okay, let's get a look at the terminal from over here. So really, well, there's nothing going by it. Am I looking at the right terminal? No, I'm not. Okay, the right terminal is, okay, so maybe I did see, just excuse my muttering. Okay, I'm going to wiggle this thing. Wow. Guess what? It's that lower wire. Got the screwdriver following it. So I did trace it to the wrong spot. It's going to that terminal. You know what that is? That's a terminal. Ta 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 ta. It's a terminal of this thing. Okay, the plot keeps getting thicker. So the terminal of this thing is hooked up to a capacitor, and there's a wire leading going somewhere. Just to add more interest, wire comes along, that's it looping up, hooks up to capacitor and this fancy looking resistor here. This $1 million resistor. Okay, so let's just do it again. Wire comes over from the capacitor underneath the chassis that I'm so interested in, ties to this terminal. This terminal carries on to this arrangement, resistor, capacitor deal, and up through the top we are connected to this apparent grid leak type resistor. The mystery empty tube resistor. Mysterious guy that it is. Okay, let's find all that on the schematic. So this would be it. This hooks up, goes straight to the plate. So a wire would come up from the capacitor underneath. Comes up and hooks onto a terminal, one leg of which connects to this apparent grid leak type resistor. The other terminal hooks up to something that goes to a capacitor resistor bridge. That's this down here. Now wait a minute. Didn't I figure out that this resistor was in fact that thing above? So what if this is the resistor? Or capacitor that were. So a wire would come up one leg to a resistor. Doesn't make sense. I'm losing it. I'm losing it entirely. I thought I had it. Now I'm looking at this. I've lost it. Okay. Let's see if I can regain it here. So the deal is, this capacitor is hooked up via this wire all the way to that terminal, which is subsequently connected to this resistor and capacitor. And look, there's even more connected to it. Oh, here's a coil. Okay, so this is the coil resistor combination. Is it right in parallel? It is. It is in parallel. There's a connection right. So this resistor is parallel with this coil. And then there's a capacitor probably going to ground. And then there's a wire going back up to this terminal here. Holy smokes, you know, I gotta draw this out. It's I gotta stop and draw this guy out. Oh my gosh.